presentation will be divided into three sections. First, I will introduce the Supermap briefly, and second, I will explain the highlight information on tornadoes movement mapping process. And last, I will show you uh, how to make the tornado movement mapping in the live tutorial. Okay, let's get started to the first one, the Supermap introduction. The Supermap was founded in 1997 by Dr. Erson Song, and approximately 20 years we have helped humans in solving various problems with GIS as the main foundation. We have about 4,000 employees spreading in all around the world, and more than 1,000 partners from more than 30 countries, and also 38 branch offices and subsidiaries. The next one is the five main key technologies of Supermap GIS software. So there are five of our main key technologies that are the basis for solving spatial problems encountered using Supermap platform. So the first one is the big data GIS. We support to do the whole process of big data, including streaming data, storage management, spatial analysis, and also the data visualization. The next one is the AI or artificial intelligence combined with GIS. So in the Supermap itself, the AI technology mainly provides for functions that are the AI for object detection, AI attribute collection, AI mapping, AI style matching or cartography, and also AI for interaction. The next one is the 3D GIS. So Supermap developed its function leads to 3D modeling from 2009 by integrating some technology like data model, scene construction, spatial analysis, and also the software form. The next one is the cross-platform GIS. So not only in Windows, Supermap also able to be open in Linux. And the last one is the cloud computing. So since 2013, Supermap available to do the GIS processing using cloud technology that allow you to do computing services, including servers, storage, databases, networking, software, analytics, and also the intelligence over the internet. Okay, the next one is the main topic of the webinar today, the mapping of movement using tornadoes, movement of tornadoes using GIS. Okay, let's get started with the definition. What is GIS? Maybe some of you are already familiar with GIS, but the rest maybe not. So, what is GIS or Geographic Information System? GIS stores information about a given area as a collection of thematic layers that can be linked together by geography or georeferencing. This simple but extremely powerful and versatile concept and has proven invaluable for solving many real-world problems, such as master planning application and infrastructure management. And in a nutshell, GIS is a computer-based database system designed to spatially analyze and display the data. There are four main components in GIS. The first one is hardware. So the desktop computers are the primary hardware components of a typical local GIS system. The next one is software. GIS software provides the functionality and tools needed to capture or input, store, analyze, and output the geographic information. The next one is data, could be a vector or raster data, and it should have a spatial information within it. And the last one, the user. So we, the human, act as a user here. Just technology is of limited value without trained operators who understand the data, system, and also the organization. Users are the only one who understands how to apply the resources to achieve the desired system. Okay, the next one is the reason why we need to mapping the tornadoes movement. So for some countries, such as the United States, due to the flat terrain and the vast area in the Midwest and South, the famous tornado corridor has been formed. And here, on average, 1,000 tornadoes will be formed in every year. The climate conditions needed for tornado formation are very complex, so it is difficult to make the timely warning. But its occurrence is not completely irregular. So by mapping the tornado, we can get its migration rule, which will be useful as a basis for making policy in the face of a tornado going forward. This is the final result of the tornado map. We can get this illustration of the tornado's migration route by monthly change. As you can see here, you can get some information. The first one is you can get the center point of the tornadoes by month. So in total it will be a 12 center point of the tornadoes. And the second one is the trajectory line of the tornado with a different color for each month. So the line surrounding the center point is the trajectory line of the tornado. By using the Supermap IDES Top 10 I version, we will retrieve these results, including the key file. It was done all by Supermap IDES Top. So in today's processing data, we will use the Supermap IDES Top 10 I version. Please refer to the link attached in this presentation to download the software for the 64 or 32-bit. Okay, the next one is the data that will be used in this processing data. So based on the tornado data from 2009 until 2018 of the US Storm Prediction Center, we use the spatial analysis function in the Supermap IDesktop to find out the migration rule of tornadoes. And we will handle thousands of data here. So to make it easier, we will analyze them per month. In every data, the data format will be in the CSV file. And in every, and then the start point of the tornado, and the last one is the end point of the tornado. Okay, for the next presentation, I will share my iDesktop screen to show you the live tutorial how to map the tornado. Okay, as you can see here, this is the visualization of Supermap iDesktop 10i version. First of all, we will import the spatial database, or in the Supermap we call it data source, by right-click in the data sources and choose the open file data source. Here we already have the tornado migration data source. You can choose the data and click open. Inside the data source, it is already exists the United States shapefile. You can right click on the shapefile and choose the add to the new map. So this is the shapefile of the United States data. The next process is we want to make sure if the coordinate system is in the WGS 1984. So you can go to the data source, right click and click properties. You can choose the coordinate tab here and click in the WGS 90 and 84. And the next step is we will import the starting point of the tornado data. So you can right click in the data source and choose the import dataset. Click add file, And now we will import all of the CSV file from the 2009 tornado until 2018 tornado. You can select all of them and click open. The next one is we will to input the spatial information of the tornado data. So in the import spatial data column here, you need to click here, and in the longitude and latitude, please choose the starting point of the tornado data. It is represented in the echelon and the echelon. So in the longitude, you can choose the echelon, and the latitude, you can choose the echelon. And do all of this process to all of the data. 2010. One by one. Okay, two more data. Okay, I advise you to recheck all of the data to make sure if you input the correct information. So right here, you can check is S1 and S1. Okay, good. We can click import here. Okay, in the workspace manager, you will find the new data set for every tornado points in the points form. And the next step is we will append all of this data set into one data set. But first, we need to create the new data set by right-click in the tornado migration data source and choose the new data set. Make sure if the type is in the point, and you can change its name into maybe T start, and click create. Next, you can select all of the tornado data, right this, and then drag them into the T-start dataset. The dataset append row will appear in here, and you need to make sure if the dataset is T-start, and then you can click OK. Okay, you can drag the T-start dataset into the main window here. So this is the dataset of the starting point, the tornado data. We can check the information by right-clicking the T-start and browse the attribute table. As you can see here, we already append the data from 2009 until 2018. The next process is we will add two new fields here for the month and the magnitude information. Actually, the month and the magnitude information already exist here, the magnitude and the month. But since the data is not in the integer format, we need to create a new one. How to make it? You can go to the properties, and in the attribute here, you can click add here. And for the first, we will create the magnitude, sorry, the month. And for the type, we will change into integer. And do the same things for the magnitude field. Here you can change the name into magnitude, and click apply. So right here, we will get the two new fields, the month and the magnitude. And the next process, we will fill this field based on the other fields. So you can click this month field and right click, choose the update field. In the operation mathematics, you will find four kinds of operation. The first one is the assign to all. If you're going to specifying a value for this field, you can choose the assign to all. And then the single field if you refer to other one field, and double field if you are going to refer to other two fields, and function if you are going to fill with specific function. We will choose the single field and refer to the MO field. You can click apply, close. So this field already filled with refer to other field, the month field. The next one is we will do the same things for the magnitude. So you can click the magnitude field, right click, update field, single field, and refer to the mag field. Click apply. So the month and the magnitude field already filled here. So the next process is we will beautify, we will make center point of the tornado by month. So what we need to do is we can go to the analysis here and then spatial statistical analysis and choose the mean center analysis. So we will, in the parameter setting here, we will group by month and use the magnitude as the weight field. And then we will add additional information, the magnitude sum. So in this magnitude arrow, we can click here and choose the statistics type into sum. We can change the name into mean center. Okay, then you can click OK. So the new mean center dataset will appear in the left side in the workspace manager. The next step is you can drag it into the main map. Okay, I will look it more better by you can double click in the mean center in the layer manager. Double click here and the styles window will appear in the right side. You can change its white into maybe 5 and the color into red. We can turn off this United States layer. So this is the final result of the mean center analysis. By using the mean center analysis, we can identify the center of density, the geographic average center, and the result is a new point, not an object in the search data. One point here is referred to 1 month, so in the total we have 12 points. The next process is we will beautify this center point. So you can right click in the mean center and choose the create thematic map. You can choose the unique values and the default. Here, click OK. So the theme map window will appear in the right side. And we will make the different color for every month. So you can go to the month group for the expression. And for the size of the point, we will make the point is based on the magnitude sum. So the bigger the magnitude sum of the tornado will have a bigger sample size. So you can click magnitude sum here, but it doesn't look proper yet. So you can rescale this size by divide it by 60 and it plus by 8. So it's look better now. This is not an exact function. You can replace this expression by your own. Okay, the next one is we will add new label here. So you can right click in the min center and then you can click the create thematic map. You can choose the label map and the uniform. Click OK. The theme map windows will appear in the right side and you will use mount group as the expression. And in the style, you can change its alignment into center. Still doesn't look proper right now. You can change the font size. Same as the previous one, you can change based on the magnitude sum. And then we can rescale its gain by divide it by 500 and add 2. Okay. The next one is we will make the label overlay with the center point. So you can go to the maps here and then choose the map properties. And here you can click the show overlays. So now the position of the label is overlay with the center point. Okay, we already kept the center point. The next process is we will create the line that connect every point here. So the first point will be connected with the second point will be connected with the third point, and so on and so forth. How to make it? We will do the conversion from the point to the line. You can go to the data here, and in the conversion, please click in the point to line conversion feature. Okay, here we will convert the min centered point into the min center line with the short field is mount group. Okay, click convert. So we get the migration route line here in the workspace manager. You can check, and then we can add this feature to the main map. You can right click here and add to current map. So this is the migration route of the tornadoes data. So you can see here that the first and the last point is not connected as well as the others. So you can draw it by your own. How to draw the line? You can double click here in the min center data in the layer manager. You can double click in the pen symbol until the color is changed into blue. And then you can click line and start to draw the new line from the start to the end point, like this. Okay, here we already got the migration route of the tornadoes. We can change the symbol by double click here. Change the width, let's say 0.5, and the line color maybe red. And I think it would be better if we take the line below the behind in the min center. So you can drag the min center here under the tornado start point. And we also can change its dashes into other style like this one. Okay. The next process is we will add new additional information, the trajectory line. And the trajectory line is need the information of the starting point and the end point of the tornado. So the line is the connection between the start point and the end point of the tornado. We already import the start point of the tornado. The next one, we will import the end point of the tornado. We can delete this first because we will not use anymore. How to import the endpoint of the tornado is the same as the importing the start point of the tornado. You can right click in the tornado migration and import dataset. do the same process like import all of the CSV data. And at the first, we already import the start point by input the S1 and S1, but right now we will import the endpoint by input the ELAT and the ELON, like this one, and do the same process for all of the data. So, and power. For more data, ELON and also ELAT. Okay, the last data. Okay, let's check again to make sure if we input the correct information. ELON, ELAT. Okay, good. We can click import. Okay, the endpoint of the dataset already appear here in the workspace manager. The next one is we will append of this data into one dataset. We can create the new dataset for the tornado and dataset first. Right here, you can change its name into TN and click create here. Do the same process by select all of the tornado endpoint data and drag them into the TN dataset and click OK. So here we already append of the tornado and data. We can browse the attribute table to make sure. Okay, we already create the TN dataset from 2009 until 2018. The next one is we will create the new field, the month field, but we will not use the magnitude field since we will not do the mean center analysis again. So in the properties of the TN, we can create the new field, the month field. We can change the name into month and change the type into integer and then click apply. And new field, the month field will appear here. And the next step is we will update this field. Click update field, single field, and refer to the move field. Click apply. Close. So we already have the month field here. Since we want to create the trajectory line between the start point and the end point, so we need a connector here that is a field that able to be found in the T start and also T end. And we will use the SM user ID as the connector between T end and also the T start dataset. But the condition now is this field in the zero number. So we can update this field and refer to the SM ID. We can right click here, update field, single field, and refer to the SM ID. Click apply and do the same process for the tornado start dataset. Click in the SM user ID, right click, update field, choose the single field, and In the operation field, you can use the SMI. Click apply. Close. Okay. The next process is we will convert the T start and the T end point into the trajectory line. You can go to the data here, conversion, and choose the point to line. Sorry, I forgot the one process. Before we make the trajectory line, we need to append this T start and also the T end point. So you can go to the workspace manager here and drag the T start dataset into the T end. The dataset append window will appear and you can click OK. You can check the T and attribute database by right click and browse the attribute table. As you can see here, the total data, the total records in the TN dataset is twice more than before. It's about the 23,000 data. And the next process is we will do the data conversion in the TN data. Go to the data, conversion, and choose the point to line conversion. Here we will choose the TN dataset that already contains the T start coordinate, the start point of the tornado coordinate, and then the end point of the tornado. And then we will use the connection is the SM user ID here that already found in the start and also in the end point. But I will not click convert here because the process is a little bit long and already prepared the data. So I can go to the uh, prepared data by import the data here. The trajectory line, you can click import. The trajectory line here already appear. You can drag it to the main window. So this is the trajectory line of the starting point and the end point of the tornado. So each line here is represent the connection between the start and the end point of the tornado. The next one is we will make this trajectory in the different symbol. So you can right click in the trajectory line and choose the create thematic map. We will make this trajectory line with different color for each month. So you can go to unique values and default, click OK, and choose the expression into month here. So every month will have a different color here, like this one. And it's better if we have a different with maybe let's say 0.5. Okay. And we also can change the transparency by right-click in the trajectory line and choose the layer properties here. In the transparency, we can change the number into, let's say, 50. Okay, it's better now. And we can change the position to be under the mean center data, like this one. Okay, the next one, we can turn on the United States shapefile and change the color. You can double click in the United States dataset in the layer manager, and in the foreground we can change its color maybe into something that different, like this one. Okay. The next one is we will change the outside color here. We can right-click in the United States shapefile and go to the layer properties. Sorry, I mean in the maps and the map properties. You can change the background color, maybe into black or blue, up to you. So this is the final result of our migration route here. So as you can see here, we got some information, the migration center point of tornado data based on the month, and then also the trajectory line for every month data with different colors. You can create a GIF file like my map like this by use the temporal data feature in the Supermap iDesktop. So we can create a GIF file like this. So in the temporal data feature, sorry, I will change the screen first. In the temporal data feature here, you can create a GIF of this tornado migration route. But I will not show you how to operate this function. Better you explore this function by your own. So here we already do all of the data processing. We already import and append the data, do the mean center analysis, connect the tornado center point, do the symbolization of our map, and the last one, trajectory visualization. If you're going to try this processing by your own, you can refer to our tutorial video in Supermap official YouTube account and download the material in this link attached in this presentation. And if you successfully got the result, kindly share yours to this link. And we will give a special gift for the participant with the best result. And more information, so this year, Supermap organized an international competition, namely Supermap GIS contest. This competition is targeted for undergraduates, postgraduates, and also PhD students. There are four categories of the competition. The first one is the mapping and the development, application analysis, and also paper. For further information, please visit our official website in the www.gscontest.com. So that's I would like to say thank you for all of the participants. And if you have any further information or going to ask something outside of the presentation, you can reach us by send email at the global@supermap.com or visit our official website in the supermap.com. Thank you.